All right, so here we are, second week of labs, and today I'm recording this lecture so that those of you who can't always make it to lab or want to go ahead and try to do this on your own and come to lab to get any help, you can do that. I'm also doing this because I have 4 lab sections, and this way I can guarantee that the content is the same across the labs. And today we're pretty much going to be going over conditional statements. And those are your use of booleans, if, then, else, greater than, less than, etc. And we're going to be going through loops, which we'll be using soon to be writing some programs. And we have 4 loops, while loops, that we'll be going over today. Now, the resources that you have available to you, are uploaded to Blackboard. There's a Mathcad manual, a MATLAB cheat sheet, and an algorithms and flowcharts PDF. So if you go to Blackboard, you'll see here's a Mathcad tutorial. This is done by a professor at another university, and it pretty much walks you through all the functions here. It's for a power electronics class, but a lot of this stuff is the same, and it answers some simple questions. And it will serve useful if you just were to go through it. It's not super long, and it has a lot of information, like I said, that will be really useful to you. There's other things on here, if you go to the Mathcad and MATLAB programming info folder in the course documents, there is a programming excerpt, which is just about programming in Mathcad, defining a program, and going through that. And some of this stuff we'll be doing today. I'll be going through this exact example, and these are on pages 267 onward. We also have the whole user manual for Mathcad. It's from, I think, 2015, but I couldn't find the one for a Mathcad 15 version that we have, but this has the functions are almost identical, so there shouldn't have any problem using that. Then we have a MATLAB cheat sheet, and this MATLAB cheat sheet basically takes you through the most commonly used functions or commands in Mathcad and MATLAB that you'll be using. For example, this is how you define a vector. This is how you define a column vector. This is how you define an array. This is how you access elements of an array. This is how you access elements of a matrix, and so on. So this is got some useful information. Solving linear equations, something that we'll be doing in this class. This is how you calculate the inverse. All right, and this is how you do some basic multiplication and whatnot. And I'll try to give you point you to any commands you might need that we'll be using along the way. So make sure you go here, and this is another one on algorithms and flowcharts. You're going to have to read through this on your own. And it's a way of us to break down steps of a program into things that are easy to identify and easy to try to then communicate to the computer. So if you look here, this is an algorithm to make a cake. So you have your recipe, and then you have your instructions, and tells you you'll get a cake for 4 people. What I want you to pay attention here is this flowchart section, because I'm going to ask you to write a flowchart. And the flowchart basically uses different symbols for each step of the program. So this would be a process, this would be an input, this is where you make a decision. If you say yes, you go this way, or if you say no, you go this way, or whatever it might be, and you would indicate that. This is a connector of different signals. This is like a process, and this is a terminal. So what this might look like is if you're creating an algorithm, you list out all your steps, and then you do a flowchart. Make sure you go to Blackboard, take a look at what's out there. And again, there's video tutorials on installing SMath and Octave. All right. So make sure you look at these resources. Now you also have in chapter 2 of your book this sheet here, which we have pseudocode on the left, and pseudocode is just basically logical statements that are software independent. So here you say if condition, then, you know, do this. This is the true block, and then end if. And then they show you how to do it in MATLAB. So here we have if b is not equal to 0, then assign r1 the value of minus c over b. Okay, so there's examples here. So if you needed to do an if then else, this is an example. If then else if, or using something called a case structure. Okay, case is when you know, something is true, then do this, or if this is the case, do this, if this is the case, do that. And we have do next and count control loop. These are not necessary to be used really in this class. Okay, we'll mainly be using if then and else if. Okay. Also, section 2.5 of your book has MATLAB examples, so I highly recommend that you read that. And again, the key to any of this software development is really to think about what you want to do first, and then you can, you know, try to figure out how to communicate that to a computer. Also, you have the help files for each of the software packages that are going to be a good resource too. Now, we said in the first lab that we had Booleans. Booleans are ways of doing comparisons or conditional statements. So we could say something is if x is less than y, then add 2 to whatever x is. Else, just leave x alone and don't add anything to it. Okay. So in MATLAB, you'd have something like this. Okay, and then in Mathcad, you'd have something like this, where we define a function. And this is an example that we're going to take a look at in a second. Okay, often we want to perform an operation on an array of data, that's just oriented sequentially, one after the other. And this could be a 1D array, or something like a vector, a 2D array, something like a matrix, or a 3D array. So this is just the way that things are organized, and the data structure is where the values are stored. Okay, and in this case we have a 1D, 2D, or 3D array. We can perform an operation either doing one by one. Let's say we had 10 values. You could actually go and get each value and multiply them by whatever you wanted to. Or we can make life easier and use a for loop and just say, you know, for every value in the loop, you know, double it if you wanted to do that. Okay. So for loops and while loops with conditionals in MATLAB would look something like this. Okay. It's better probably to do that with an example. I downloaded it from the instructions that I gave you, and I just reoriented it here by dragging these things around. I think it was something like this when I first opened it. Dragged it over here so that things would look more similar to our MATLAB environment. Okay, and here I just want to say I want to have an array, say, of x values that are equal, okay, from 0 incremented by 1 to 10. Okay, and then I'm going to hit F5, which runs the program, and then it's going to ask me to save the file somewhere. Okay, for this I'm going to try to go to my numerical methods, and I'll say this is lab 2. Okay, so I'm going to just change my directory so that I can run this file, and you can see my directory changed to where I just saved that file. Alright, so here we are. We have opened up Octave, and I've moved things around. Okay, so you can just drag these windows around and move them where you want, and I've moved them to where they are close to where I want them to be. So what I've so we've already saved the file. Now that we have the file, it's a good practice to go ahead and do CLC, which is clear the screen. See if you have garbage down here, you can type CLC and it gets rid of it. Here, if you have variables, you want to clear them so that variables from old programs don't get stuck on new programs. And anytime you can highlight the text and you can hit it, and it can run, actually in MATLAB it runs here. Okay, it's supposed to run as well, but it didn't run when I hit F9. Maybe I have my function lock on, but regardless. So here we're talking about defining an array of data. So for here in Octave or MATLAB, it's the same. We can define an array X from 1 to incremented by 1 to 11. Okay. Okay, so if we do that and we hit F5, then we have from 0 to 11. Okay, or we can go from 1 to 10 just by changing the index, running it again. Okay, now we go to 10. Now, there's two ways. Say if I wanted to double each value here, and I say x, I could just do x equals 2 times x, and this is MATLAB format, which is Matrix Laboratory. Of course, we're in Octave right now, but MATLAB knows that you can multiply a scalar through all elements, so it can just double them. So you get the first x, and then you get the second x, which is just double the first x. But let's say we didn't want to do that, but instead we wanted to create a new variable y, okay, that was equal to 2 times x, and let's say we couldn't actually multiply them all at once, that we had to multiply them individually. And there's going to be times where you want to do things individually. What we can do to do that is we can do a for loop. So we can do for I equal from 1. Okay, that means we're going to be going through the first element all the way to the last element, which is 10th. So we can see how many elements are here. So either we can go from I as 1 to 10, or we can actually use another command, which is the length command. Okay, length. So once you start to type, you can get this syntax here. It'll give you a hint of functions you can use. You can just hit tab to use the one that you want. So we can do for the length of x, okay? And that will say, hey, I want I to go from 1 to however big x is. That way we don't have to look over here and see how big x is, you know, and hard code it. We can just use the length command. Okay. Now if we use the length command down here, okay, length, okay, of x, this should be 10. Okay, so it tells us that we have 10. So we know that this is going to go from 1 to 10. So we say for I equal 1 to length of x, we want to assign y of I. Now y is a new variable, and we're going to be putting the ith element as 2 times the x element. Okay, now this is where it might be useful to suppress the output. If I put a colon there, semicolon there, it will keep it from, you know, updating each time. But I'm just going to show you what happens when we leave it off. Okay, and then we're going to do end. And end closes the loop. So we're going to, for each I going from 1 to the length of x, we're going to say y of I is equal to 2 times x of I. Okay, so each time I is going to change. First time through is going to be y1. Second time it's going to be y2, x2, y3, x3. Okay, and each time I'm going to assign twice the value of x to y. If I hit F5 and I run that, you'll see that first I have my x values from 1 to 10. Okay, I did not suppress the output. And then I start to go into my loop. I get my first value, y, is twice my x value. Okay, and then I get my second value I, which is twice my x value, and then I get my third value, and then at this point in time Octave is saying, hey, look, I don't know how long we're going to be doing this and printing these out. Do you still want to do this? If you can, go ahead and go forward, or you can go back a loop, or you can just quit. So what I'm going to do is I'm going to just go forward and show you that it gives me all the values. This time I'm going to run it again, and if I didn't go forward, okay, if I went Q and quit, okay, here, oops, I typed the Q up here. You have to be in the command window. Hit Q, okay, then it just stops. But if I type Y, it shows me the whole value. So what it's asking you really is, do you want to continue to print the output? Okay. Now you can also run a file. This file is called lab2 by just running the file name. So if I do lab2, it runs it again, and then I can do forward, and it does that. Or I can just come here and I can suppress the output, and then I'll come down here and then I'll put Y, because I want to know what Y is. So it will give me X, it'll go through the loop, we won't see anything, and then we'll come down here and look at the result Y. So if I hit F5 again, you see we just have X that goes from 1 to 10, and Y, which is double the X value. Okay, so this is a very basic example of how we go through each element in an array. We can also do this for a matrix as well. All right, so now the question is, well, how do we do the same thing in Mathcad? And here Mathcad and SMath are going to be a little bit different, and I'll have to figure out those differences later, but I'm going to show you how to do this in Mathcad. Okay, so here in Mathcad, first thing we need to do is talk about range variables versus vectors. Okay, so a range variable is just a variable that is defined beginning to end and cannot really be randomly accessed. For example, if I had a range variable I, and I can go up here to my tool palette here. This is my matrix palette. I think you can also get to it. See here. Here, okay. This is the matrix palette. I think we can pull it out here. See here. There we go. If we double click, we can also pull it out so that it looks the same as what you have. So we can have I. And this will be our index, and we can click here and it says range variable. Okay. The other way we can get to this if we hit semicolon, okay, and that'll bring up range, and we can go from 1 to 10. Okay. Now, before we could access in MATLAB or Octave randomly, so we could say like I, and here we can do open bracket of 1 and try to get that first value, but here we get an error that says, hey, this value must be a vector. Okay, so that's frustrating. This, you can beat your head against the wall for a while. So, but no worries. Instead of this, what we have to do is just define a new variable. Okay, this will be vector. Okay, and our vector is just equal to we can do vector, and we have to do down here we have to do open bracket. Okay, and we'll select the range variable I. So that means we're going to populate a vector with the range of values in I, and we're going to say it's equal to 1 times I. Okay, so now we have a vector. So then we can say, okay, well, what is vector equal to? Okay, and notice we don't have to do vector of I. We can just do vector. Okay, what is that vector equal to? We drag it down here so you can see it. Okay, or we can do a vector, and we can do open bracket. Let's say we want to pick the first value. Okay, so that'll give us 1. Okay, if we want to come down here, I think, let's see here, what if we do 0? Okay, it gives us 0. So our I goes from 1 to 10. Okay, vector of 0 is 0. Let's see, I don't even know if we have a 0 element in our vector, do we? Okay. So this goes from 1 to 10, 0 to 10. Same thing. So for whatever reason, if we go from 5 to 10, it still gives us a vector of I. So I guess I automatically starts at 0 here. Okay, no matter what our I value is. Even though we had it defined from 1 to 10, it still gave us the 0 value, okay, because it still took I from 0 all the way to 10 when we created the vector, okay, and of course I 0, and this is x of I here. This is our value. So these are the indexes, the index from 0 to 10, index from 0 to 10. Now notice if we come down here and we say I, and we only define I from 5 to 10, well, that means all the values before this 5 are actually 0. So this is your range variable. Okay, if we go from 7 to 10, everything is 0 before 7. If we go from I to 10, we're going to do that. Now, if we know that we just want to go from, say, 1 to 10, then down here we could use our vector variable, open bracket, 1, okay, and pick that first value. Okay, so what we could also do is we could create a program. So now this is where we want to do the same thing that we did in MATLAB, where we actually created a program. And this is an example that we're going to go through. This is page 267 to 272 in your Mathcad user manual uploaded to Blackboard. And we're basically just going to create a program, simple program to define this function. Okay, and so here's all the steps. I don't expect you to be able to read them from this presentation. You really need to go to that file and open it, but we'll walk through it right here. Okay, so the first thing we're going to do is create an f of x comma w and define it as equal to something where we're going to add a new line in the programming window. Okay, so we'll get rid of this for a moment, and we'll come here and we'll do f open parentheses of x comma w, oh that's a y, w, close parentheses, colon equal, and now here we are, we only have one line, so what we can do is we can go over to this programming menu and do add line, okay, and that gives us a whole nother line. Alright, and then what we'll do is in that vertical bar we're going to assign a variable z the value of x over w. Okay, so the way we do that is we type in z and then we do the assignment. This is the assignment variable or local definition. That means we're inside of our function, we're going to define a variable and we're going to put the result in whatever's on the left hand side. Okay, so in this case this is going to be, I think it was, what is it, x over w. Okay, x over w. Okay, and so here we can just do x divided by w. Okay, and then down here we're going to take the logarithm. Now instead of, now not all functions, so I can type log and do open parentheses z, okay, and see if it runs, and do f of say 1 comma 2 and see if my program runs. Okay, and it does run, but it doesn't work out all the time to where if we type in a variable that we get the same expression that's over here, and that works for things so sort of like the if statement. You can't just type if, you actually have to do a open curly brace, I mean a close curly brace as a shortcut key, or come over here and click the if button. Okay, so this is a simple function that we've defined. Okay, we said this is a function, this function we want it to be to calculate the logarithm of two parameters that we pass into the function, x and w. Okay, and we did that by saying f of x of w is equal to, then we had the right hand side, we added a new line. That new line gave us another line here, and then here we assigned the variable of x over w to z, and then we said the log of z. And then we can use that function here. We can do f of 1 comma 2 and then do our evaluate expression, which is different than our define expression. Okay, so that's a simple way for us to write a program. Okay, and you can see that that function works. Okay, now we can write another function, and this time we're going to use an if statement. Okay, so let's go ahead and get rid of this, and we'll do f of x, okay, colon equal, and then we're going to get our new line. Okay, and then we're going to say that this value is equal to, okay, and this is going through the example in your notes. Okay, we're going to say the value is equal to 0 if, okay, so first I think we actually need to do our if, okay, our if statement. We don't need to do the assignment variable. I'll show you what I mean. So instead of putting something here, what we need to do is click on this if statement. Now if you highlight, if you hover over these different commands, you're going to see the shortcut key. For the if statement, it's the open curly brace. So I can do shift, close curly brace, and it gives me the if function, and I'm going to put the 0 here. So it's going to be 0 if whatever I put over here is true. Okay, and here I'm going to put a conditional statement. That conditional statement is going to say if, now I'm going to use the absolute value, and that's different than the determinant, even though they look the same. Okay, all right, so the way we call them is the same, is by using the open brace, okay, the straight brace, and I can say if the absolute value of x, and here I need to do a Boolean comparison. Here's your Boolean palette over here, If you double click it, it'll pop it out. Okay, and we'll say that if the absolute value of x is less than, if the absolute value of x is, okay, when I hit back, you see the spacebar went inside it. So here I can hit Control spacebar, and that'll bring me out of that expression, but not out of the whole expression. If I continue to hit Control spacebar, it'll bring me out of everything. I don't want that. I just want to get right next to that x. So in this case, I'm going to say if the absolute value of x is greater than 2, okay, is it greater than? Okay, if it's greater than 2, make it 0, and then I'm going to come down here and I'm going to select this remaining placeholder, and I'm going to click otherwise, and that is a control curly brace. Oops, wrong expression. Okay, here's otherwise, and that's going to be a control shift otherwise. Okay, and in this case, I'm going to say that if the absolute value of x is greater than 2, make it 0. Otherwise, give me the square root of 4 minus x squared. So otherwise, give me the, I'm going to come over here to the square root. Okay, and here we can either do the slash on the keyboard. Okay, it's going to be the square root of 4, what do we say here? Minus x squared. Okay, so this is basically saying if it's imaginary or it's negative, then, you know, we're just going to call it 0. Okay, x. Okay, we can do shift caret squared. Okay, and then we have our function defined. So what we can do is we can actually plot this function, go down here to our xy plot, put our function here, f of x, okay, and then see what it does. Okay, and now notice we can't really see everything, so we actually can click on the graph, and then we can come up here, we can make this 2. Okay, and we can come down here and make this minus 2. Oop, what happened? Nope, I hit 2 and 2. We need to make this minus 2. Okay, all right, so here we can see that this is the function. Okay, it's defined, and maybe it'll be a little bit easier to see if we take this function from minus 10, minus, oh, I guess when you do that you have to delete the whole thing. So it's going to be, let's take it from minus 4 over 2, excuse me. Alright, if I hit control space, it'll bring me out, and then I can do 4. Alright, so that's a little bit easier to see. So we can see, you know, here's our minus 2, here's our 2. So if the absolute value is greater than 2, it's 0. So it's going to be 0 here and 0 here. Otherwise, it's going to be this function, 4 minus x squared. Okay? So this is a way of writing this, actually a program, okay, where we said f of x is equal to something. We're passing the parameter x into our program, okay, and then we're doing an evaluation. We have a conditional statement and an if statement. So if this is true, make it 0. Otherwise, make it this. Okay, so this is an example of how you program a function in Mathcad. Now, we said that we wanted to do the same thing that we did in MATLAB with a for loop. Okay, so now what we could do is we could say f of x. Okay, we could get rid of this. Okay, we can say f of x. Excuse me. Let me delete this. F of x colon equals. Okay, add a line. We can say for every I contained from 1 dot dot to 10. We could say x open bracket I equal is assigned, okay, 1 times I, 1 times I, and then down here we will just print out the result of x. Okay, and there's a problem with our syntax. So here we have to do from I contained from, I think we may need to put a range variable, 1 to 10. Okay, x of I is 1 times I, and if we do no matter what f of x is, we should get the same result. Okay, so that gives us our values from 1 to 10. Okay, now we didn't actually pass a variable in. Okay, so what we could do in order to use this variable, okay, so we could say x, we could make this a variable. Okay, we could say for I equals 1 to x. Okay, so here x is 1, so we put a 1 in, so it's going to go from actually 0 to 1 because it's an array variable, or we could go from 10. Okay, and it gives us the 10 values, so we could go to 100, and it gives us all the way to 15, dot, dot, dot. Okay, you can click on that, get all your values all the way to 100. Okay, so you can see this is two different ways to calculate things in MATLAB and Mathcad. This is using a for loop, okay, and this is a basic function to see how that works. Okay, whatever variable you leave here out on the end, okay, that's the variable that's going to get printed. Okay, so in this case, if we do f of 5, okay, then the x value, which is calculated in each time through this loop, and this loop pretty much is here. Okay, so we're saying from I contained from 1 to x, where x is a parameter we pass in this case it's 5. Okay, then calculate 1 times I. Okay, now I actually goes from 0 all the way to 5. Even though we say going from 1 to x, we're actually only performing the calculation from 1 to x. And if I said, okay, from 4 to x, perform the calculation, then all these values will be 0 here. Okay, so hopefully that's clear what's going on right there. There's a lot of information packed in there, so make sure you understand the syntax and ask any questions if you have any questions. Something to keep in mind is that when we create a value in Mathcad, it's 0 based. Okay, so like let's say we created a matrix, okay, a 3 by 3 matrix, okay, and if I hit control space, I come out here, I can say x colon equals put my matrix over here. Okay, and if I say 1, 2, 3, 3, 2, 1, 1, 2, 3, okay, and then if I wanted to access the first element, what I could do is I could say x colon 0 comma 0, and then I could do equals, and that'll pull out that first value here. Okay, if I make this -1, you see this changes to -1. Okay, that's important because in Mathcad, this is what's called 0-based indexing. Okay, where this is my 0, 0 element. Okay, in MATLAB and Octave, it's not like that. So if I created a matrix here, A, that's equal to open bracket 1, 2, 3, semicolon 3, 2, 1, semicolon 1, 2, 3. Okay, and I wanted to take a look at this A matrix here, this A value. Okay, and I could do A, sorry, come down here and I do A open parentheses 0 comma 0, I'm gonna get an error. Okay, because subscript indices must be either positive integers less than 2 to 31 or logicals. Okay, so the error came from lab 2 at line 11, so that's this line. So if I want to access that first element, I would have to do A11. If I run it again, then I get no problem. The answer is 1. Okay, and if I change this from -1, then the answer is -1. So when we're talking about writing programs with matrices, it's going to be very important that you pay attention that if you're in MATLAB, that in MATLAB you're going to use 1-based indexing, where we start at 1. So this is A11, A12, A13, etc. Okay, but if we're in Mathcad or in SMath, we have different indexing. It may be actually different than SMath. So let's see, this is S math, and let's take a look at its indexing. If we have A colon equal, we go over here and create a matrix, and we'll do a 3 by 3. We'll do -1, 2, 3, 3, 2, 1, 1, 2, 2, 3. And how do we get in here? So let's say we wanted to do A open bracket 1 comma 1 equals, that equals -1. So in S math they actually use the same indexing as in Mathcad. This is not a big deal. This is more or less just understanding where the data starts. Okay, so let's see here. Let's do one more example here in Mathcad. So what we're going to do is we're going to define a value v, and we're going to do underscore m, and we're going to have this is equal to, we'll come over here to our range variable here, which is semicolon. So this is going to be equal to 0 to 2500. Okay, let's see what we did wrong here. M, sorry, forgive me. So this is M. So this is our range variable, 0 to 2500. And then we're going to have V of M, which uses our range variable, and it's going to be equal to 1 plus the sign of M. 1 plus the sign in here. So your sign of M. Okay, so that, it's going to define. So if we do phi, there's, tons and tons of values. So, and then here we're going to have a while loop, and I'll show you the difference between a while loop. Well, while loops just say while something is true, keep on keeping on. Okay, and in this case we're going to say t of v and thresh is colon equal to. So we'll say t of v and thresh, okay, is colon equal to, and we're going to add a new line for programming. Okay, and this is going to be, we're going to have a counter j, and our j we're going to initialize to be 0. And the reason we do that is because when this loop runs, if we come into the loop again and we don't make sure that j is 0, it might start off where it left off the last time. Okay, and then we'll say while v of j is less than or equal to the threshold, increment j. Okay, so down here we're going to go over and we'll do a while. Okay, so while, we said while v of j, so while v, and we'll do open bracket j to get down there to the index, and we say that while it's less than or equal to our threshold variable, which we're going to pass into this function. Okay, so while this is true, okay, we're going to have to do this condition, and this condition is basically going to increment j. So we're going to say, well, j is just going to be whatever j is plus 1. Okay, and then we're going to add a line. Oops, not there. We're going to hit control space, and we're going to add a new line outside of this while loop. Now notice how I was here, I hit control space, highlighted here, and then here, this is still in the while loop. So I have to hit control space again to bring me completely out of the while loop. And then I'll come down here and I'll put j. So j is the output. J is going to be the index variable. Okay, so let's see here. So this will tell us the index where the first element is less than or equal to the threshold. Okay, so if we want to know what index where this v of j, which is this function 1 plus the sign of m, if we want to find out the first time that this variable is less than or equal to the threshold, we can use this function. Okay, so if we choose 1.98, so if we say this is our function, we defined a function, this is a program that we wrote to help calculate the value for this function, and then to use the function we can say, well, t of v, now that v is going to be this variable. Okay, V of m was used to define that we're going to say that this is the range variable from 0 to 2500. There's going to be v values where the value is 1 plus the sign of m, where m goes from 0 to 2500. Okay, and it's the same v variable that we're passing here, but we don't necessarily need to have this index because Mathcad knows that we're using that v, and we're going to put in our threshold, and here we're going to say that's 1.98 close parentheses, and then we'll do our evaluate. So we're evaluating that function. So here it says, well, when j is equal to 8, that's the first time that this is no longer true. So we'll come in here and look at v, we'll do evaluate, and we'll come down here to the 8th value, and we see that it is actually true that the first time that our v value is less than our threshold, less than or equal to our threshold of 1.98 is right here on the 8th value. So here we have 1, which is less than 1.98. Here it's less than, here these are all these values are less than 1.98 all the way until we get here, and this is 1.89. So it's 0.0099 thousandths greater than our threshold, and so it's going to find that our index, this is our index, this is j. That's the first time that it's greater than, Alright, so your assignment for lab this week is to go through all these exercises and make sure you understand them.